Yes, dear students. Now let's see question number 3. What does valency mean? Give some examples. What is the meaning of valency? Let's see. The capacity of an atom to combine with the other atoms is known as valency. You know, we have studied, when I explained you this chapter, that time also I explained you that what is valency, that it is a capacity of an atom, any atom, when it combine with the other atoms. So how much it is capacity to combine with the other atoms, that capacity is called its valency. Okay, so its examples are: hydrogen has one valency. Here why you write valency? So oxygen's valency is 2, means hydrogen has single valency, it can combine with a single atom, and oxygen has 2 valency, means it can combine with 2 atoms or any 2 other same kind of molecules. So question number 4 is: classify the followings as elements and compounds. Children, here they have written name of some of compounds and some elements. Just like this: carbon, water, oxygen, nitric acid, sodium, hydrogen, calcium carbonate. So let's see, I have sorted out or classified these into 2 different columns. First column I have made for elements. So what are the elements here? That I put in this first column, and rest of the compounds I have written in second column. So first column is regarding elements. Here carbon is given, so carbon is a element. Oxygen is also an element. Sodium is also an element. Hydrogen is also an element. So here these names we have to write in elements column, and rest of the compounds are: nitric acid is a compound, okay, and water is also compound. You know that water formula I have told you, that H2O is a water, so it is a combination of hydrogen and oxygen, so it is a compound. Calcium carbonate, it is also a compound. So 3 name of compounds are written here, but rest of all are elements. Okay, so next is question number 5. Write the symbols for the followings. First is, here they have given a list of 5 names, means 5 element name they have written here: calcium, potassium, sulfur, chlorine and oxygen. Okay, so let's see what is the symbol for these elements. Calcium symbol is Ca, capital C and small a. Potassium symbol is only K, it is a capital K. Okay, single capital K is a symbol of potassium. Sulfur symbol is S, capital S. Chlorine symbol is Cl, C capital but L is small. Oxygen symbol is capital O. Okay, so after this, children, next are the long answer type questions. First question is: define elements and compounds. So in this, first we define element. What is element? Element is a substance which is made up of only one kind of atoms and cannot be broken down further. Here children, element, you know that it is the smallest particle, or we can say it is the simplest form of any element or any kind of particle, and it is made up of only one kind of atoms. Understand? So they cannot be further broken down, so that's why they are called as elements. Here we have studied about these elements. These are the name of elements and these are the symbols of some elements. 5 elements they have given here. Except these, you can write here nitrogen, hydrogen, helium, and so many other elements are also there. Okay. After this, compound. What is compound? Compound is a substance formed by two or more different elements joining in a chemical reaction. Children, all the time when there is a formation of any kind of compound, chemical reaction is necessary. You know that when any compound is formed, it can only be formed by undergoing the chemical reaction, and they are always chemically combined compounds, or we can say they always present in a fixed ratio. Okay, so just like I have explained you about water. Water has a H2O. H2O means two hydrogen and single oxygen. When combined together, then only they can form a molecule of water or compound of water. Okay, we can't say that when hydrogen 2 atoms or oxygen 2 atoms when combined together then they can form water. No, that can be another compound or another kind of chemical. But when we can say it is a water, then only its requirement is a fixed ratio of 2:1, means 2 hydrogen are required to form a water compound, and 1 or single oxygen is required to form a water molecule. Understand? So children, this is about the element and compound. So next question number 2 is, what is atomicity? Write a short note on atomicity of common elements. Children, what is atomicity? Let's read its definition. The number of atoms present in one molecule of an element is known as its atomicity. You know children that when we talk about the atomicity, we can check that how many number of atoms are present in that molecule. On the basis of number of atoms, we can define that whether the atom or whether the molecule is monoatomic or diatomic or tetraatomic or pentatomic. Okay, so on the basis of number of atoms present in any molecule, we can decide that this is its atomicity. Okay, so let's see here. Question they have given that write a short note on atomicity of common elements. So in your book I have explained you about some of the elements. So some elements exist singly in nature. They are called monoatomic molecules. For example, helium, neon, sodium are monoatomic. You know, then when we write helium, we only write He. Okay, means this is the symbol of helium. And when we write neon, then only we write Ne. Okay, so this is the symbol of neon. And when we write sodium, we only write Na, not So. Okay, Na we write. So means they exist singly. We can't write any subscript with that He2 or Ne2, not to write like this. So these are called monoatomic because they exist in nature in single form. Okay. So next, some molecules consisting of two atoms which are called diatomic molecules. So what are the examples of diatomic molecules? Nitrogen, hydrogen, oxygen are diatomic. In these all the names, you know children, when we write about nitrogen, symbol of nitrogen, or we can say molecule of nitrogen, then always we used to write N2. Here for hydrogen we write H2, oxygen we write O2. So they exist in a diatomic form. Okay, means two nitrogen they combine together to form N2. So that's why we write diatomic, or we can say in a diatomic molecule they exist. These molecules means nitrogen, hydrogen, oxygen, they are the examples of, these are the examples of diatomic molecules. So similarly, phosphorus is tetraatomic. Tetra word we use for 4. So phosphorus is a tetraatomic molecule and it consists of 4 atoms, and always we write for phosphorus is P4, like this. Means P we write capital and 4 we write as a subscript. Okay. So children, this is about the atomicity and its short note I have given you. So next are the question number 3. Balance the following chemical equations. Here they have given 4 chemical equations which are not balanced. Here first one is sodium plus chlorine, they gives sodium chloride. But here you see children, I have told you that when we check the balanced equation, whether it is balanced or not, we should check the reactants as well as products. Number of reactants or number of products, how many are there. Here you can see one atom of sodium is there and here one atom of sodium. It's okay. But here 2 chlorine atom are there, but in product only single chlorine atom is there. So it is not balanced equation. How many atoms are present in products, that much atoms should be present in the reactants also. So we have to balance. In the same way, all the reactions, all these 4 reactions are not balanced. So these reactions we have to balance. First one, you see, when we if we write 2 here in front of sodium, then we can see here in front of sodium we write 2, and here also if we write 2, then it can be written as a balanced equation. Okay, you see that this 2 means 2 sodium and 2 chlorine. So here 2 chlorine are there, here 2 sodium are there. So this equation is balanced. And second one is 4. If we write 4 in front of before this aluminium, and 3 if we write before this oxygen, Then after that here we can write 2 in front of aluminium. So then we only can say that this equation is balanced. But here you can see that aluminium single and oxygen O2 only they written, and Al2O3 they have written. This is not balanced, but in this way when we try to balance them, then we should write here 4 and in front of oxygen 3, and in front of this, before this aluminium oxide, when we write 2, then it only be in the balanced form. Okay, so here third one is also in the same way. Here you see Na2O plus H2O and it gives NaOH, but it is also not balanced. Here we can balance it in this way, Na2O H2O, but here we should write 2 in place of here. You see this, here nothing is written, but if we write here 2, then all the atoms, we can count the number of atoms in the product and reactant, both are the same. And in fourth one, here sodium, they have given sodium plus water. So with sodium if we write 2, and with water also if we write 2 here, and in products also we write 2 NaOH plus H2. So this is the balanced equation, and here if you count the number of atoms in reactants, they remain the same as the number of atoms or in case of products. Okay, so children, in this way we can balance the equation. Next, question number 4 is explain with an example the steps to write a chemical formula. So how to write a chemical formula? We should follow some steps. So what are these steps? Steps to write the chemical formula are: write, first is write the symbols of the constituents elements. You know children, these are the chemical reactions. You can see here also that when we write any chemical formula, suppose NaOH when we want to write, or Al2O3 when we want to write, then how we can write? First we write symbols of these. Symbols means aluminium symbol is Al and oxygen symbol is O. Okay, so this means that first point says that first we write symbols of the constituent elements, means what we are using to write the constituent. First we write those. After this, second point is write the valencies under the respective symbols. In book, I'll show you from the book also, that in book also they have given, I have explained you this thing also. See, first we write symbol of, suppose we want to write formula of water. Okay, so first we want to write this symbol of this hydrogen and symbol of oxygen, because these both are the constituents of water. What are the constituents of water? Hydrogen and oxygen. So first we write these symbols of these both the constituents. After that we write valency below these. You know that hydrogen valency is 1 and oxygen valency is 2. So after that what we do? We will cross the valencies. Means oxygen valency we cross with the oxygen we cross with the valency of hydrogen, and we should cross the hydrogen with the oxygen valency. Okay, so here what we write? how the formula we write now? H2 and O single. O is single there. So when single is there, we should not write any subscript. So H2O is the formula of water. So this is the step, these are the steps when we want to write any formula, we should use this. But third point is, if valencies have common factors, simplify them. You know that we have to simplify the factors also. See this is also can you explain from the book? You know that here when we write the formula of carbon dioxide, here you see that their constituents are carbon and oxygen, and when we write valency of carbon, it is 4 and oxygen valency is 2. So they are having we can say they are divisible by 2. So we simplify them again. So when we simplify them again, then we can write that here its formula is CO2. Okay, how? Because 2 ones are 2 and 2 twos are 4. Okay, when we cut both these, because they come in a single table, so when we simplify them, then here carbon has only one valency, it remains only 1 here. When we cut this and we write 1 here, then carbon has 1 only left, so 1 we not write, and here 2 twos are 4, so this we cut and write here 2. So oxygen has 2, so its formula will be CO2. Understand? So in this way we can write down a chemical formula of any compound. So fourth point they have written that about the interchange, that cross when we do. Now interchange the valencies and write them as subscript. Means after crossing we interchange the valencies and then we write as subscript how much it is coming, like just like H2O or CO2. Okay, in this way 2 is a subscript. And after that, question number 5 is write the chemical formula for the followings. Here 4 compounds are there: hydrochloric acid, sulfuric acid, nitric acid, and common salt. Common salt means which we use in our daily life in our table salt, in the form of table salt, that is common salt. So what is their chemical formulas? Let's see. Hydrochloric acid formula is HCl, hydrochloric acid, and sulfuric acid formula is H2SO4. In the same way, nitric acid formula is HNO3, and common salt is a sodium chloride. Its formula is NaCl. Okay, children. So these are the question answers of this chapter number 4. So all these question answers you should write in your notebook, and after completion of notebook, then this chapter is coming in your July test. So after completion of your notebook, you submit your notebook for correction. Okay, I'll send you pics of these pages also, but I want to explain you about these question answers so that you should understand properly, because this chapter is coming in the test, July test, your first UT. So you should be learn properly and thoroughly. Okay children, So Jai Gurudev.